100 things about our solar system they never taught you in school. The problem is simple. Most of us got a basic 8 planets in a line explanation in school. Some of us got 9 planets and then moved on. But that version is way out of date. We've found dwarf planets, strange moons, rings made of dust and ice, planets tipped on their sides, storms bigger than Earth, and even objects that blur the line between comets and asteroids. So let's fix that. Let's rebuild your mental picture of the solar system in 100 steps. We'll start close to home with the sun, work our way out past the planets, through the asteroid belt, the icy edge regions, and even out into the invisible bubble that protects us from deep space. Along the way, you'll see how weird our neighbors really are, why the solar system looks the way it does, and how tiny Earth actually is in the big picture. And because this is 100 things about our solar system, you can almost treat this like a checklist. Every new thing adds one more piece to the puzzle of how our little system in space really works. See how far you get before you fall asleep. If you fall asleep before you reach 100, then you have to come back and try again. All right, let's jump into number 1. Number 1. The sun holds almost everything. Our star is not just the biggest thing in the solar system. It's basically the whole thing. The sun contains about 99.8% of all the mass in the solar system. All the planets, moons, asteroids, and comets together share the last tiny 0.2%. That means you, me, Earth, Jupiter, everything is basically crumbs left over from the sun. Number 2. The solar system is about 4.6 billion years old. It started as a huge cloud of gas and dust in our galaxy. Something disturbed that cloud. It started to collapse under its own gravity. It spun faster and flattened into a disk, and the sun lit up in the middle. The stuff left in the disk clumped together into planets, moons, and other bodies. Number 3. The sun is a pretty average star. We often treat it like something special, but in star terms, it's middle of the road. It's a yellowish dwarf star. It's not the biggest, not the smallest, not the hottest, not the coolest. That's actually good news for us, because stable, long-lived stars like the sun give planets a long time for life to form and evolve. Number 4. The sun is not solid fire. It's a giant ball of superhot hydrogen and helium gas. The light and heat come from nuclear fusion in its core, where hydrogen atoms are forced together into helium. That process releases huge amounts of energy, which travels outwards and eventually shines into space as sunlight. Number 5. The sun is huge compared to Earth. You could line up about 109 Earths across the diameter of the sun. If the sun were a big front door, Earth would be about the size of a small coin. You could also fit about 1.3 million Earths inside the sun if it were hollow. Number 6. Planets all orbit in the same direction. If you look down from above the sun's north pole, you'd see all the planets going around in the same direction, counterclockwise. That's because they were born from the same spinning disk of gas and dust, so they inherited that spin. Number 7. Planet orbits are not perfect circles. We often draw them as circles, but technically they're ellipses, slightly stretched out. Some, like Earth's, are almost circular. Others, like Mercury's, are more oval. This shape changes how close they get to the sun at different points in their orbit. Number 8. There are 2 main families of planets. The 4 inner planets, Mercury, Venus, Earth, and Mars, are small, rocky, and dense. The 4 outer planets, Jupiter, Saturn, Uranus, and Neptune are much bigger and made mostly of gases and ices. This split is important for how we think about habitability and planet formation. Number 9. Mercury has extreme temperatures. Because it's closest to the Sun and has almost no atmosphere, Mercury's surface can get hotter than a pizza oven during the day and then drop to freezing cold at night. We're talking hundreds of degrees difference between day and night. Number 10. Mercury has no moons. You might think every planet has at least one moon, but Mercury has none. Its small size and closeness to the Sun make it hard for it to hold on to a natural satellite. Any captured object would likely get pulled away by the Sun's gravity. Number 11. Venus is hotter than Mercury, even though it's further from the Sun. Venus is wrapped in a thick atmosphere made mostly of carbon dioxide with clouds of sulfuric acid. This creates a runaway greenhouse effect that traps heat so well the temperature on Venus can melt lead. It is one of the most extreme examples of greenhouse heating we know. Number 12. A day on Venus is longer than a year on Venus. Venus spins incredibly slowly. It takes Venus longer to rotate once on its axis than it does to complete one orbit around the Sun. So if you stood on Venus and somehow survived, the time between sunrises would be longer than a Venus year. Number 13. Venus spins backwards. Most planets, including Earth, spin in the same direction they orbit. Venus spins the opposite way. That means if you could see the Sun from Venus's surface, it would appear to rise in the west and set in the east. Number 14. Earth is the only known planet with liquid water on the surface. We see ice and maybe underground liquid water elsewhere, but Earth is the only world we know for sure that has stable oceans of liquid water on the surface. That's one of the reasons life thrives here. Number 15. Earth's atmosphere is unusual. Our air has a lot of oxygen, which is actually a very reactive gas. In most places in the universe, oxygen doesn't just sit around like that. On Earth, plants and tiny organisms keep pumping fresh oxygen into the air, and that constant renewal is a sign of active life. Number 16. The Moon is unusually large for a planet like Earth. Compared to its planet, our Moon is huge. Many scientists think the Moon formed when a Mars-sized object slammed into the early Earth. The crash blasted out a ring of debris that later clumped together into the Moon. Number 17. We only see one side of the Moon from Earth. The Moon rotates at the same rate that it orbits Earth. That's called tidal locking. Because of that, the same face of the Moon always points towards us. The other side isn't dark all the time, but it is hidden from direct view from Earth. Number 18. Total solar eclipses are a cosmic coincidence. The Sun is about 400 times wider than the Moon, but it's also about 400 times farther away. That match in size and distance means the Moon can just perfectly cover the Sun as seen from Earth, creating a total solar eclipse. Over long timescales, this will change as the Moon slowly drifts away. Number 19. Mars is red because of rust. The reddish color of Mars comes from iron minerals in its soil that have reacted with oxygen, forming iron oxide, basically rust. That fine dust covers the surface and gets blown around in storms, giving the planet its rusty look. Number 20. Mars has the largest volcano in the solar system. Olympus Mons is roughly 3 times higher than Mount Everest. It's so big that if you stood on one side, the curve of the planet would hide the other side from view. Even though it's a volcano, it's thought to be inactive now. Number 21. Mars also has a canyon system that dwarfs the Grand Canyon. Valles Marineris stretches for thousands of kilometers and is several times deeper and wider than the Grand Canyon. It's like a giant scratch across the face of Mars, possibly created by tectonic forces and erosion. Number 22. Mars has two tiny moons. Phobos and Deimos look more like lumpy potatoes than our round moon. They're probably captured asteroids or leftover pieces from ancient impacts. Phobos is slowly spiraling inwards and will either crash into Mars or break apart one day. Number 23. Between Mars and Jupiter sits the main asteroid belt. It's not a wall of rocks like in movies. It's a huge region where millions of rocky bodies orbit the Sun. They're spread out so much that a spaceship could fly through the belt without hitting anything, as long as you weren't aiming for an asteroid. Number 24. The asteroid belt is leftover building material. These rocks are bits of the early solar system that never combined into a full-size planet. Jupiter's strong gravity kept them from merging into something bigger. Studying asteroids helps us understand what the early solar system was made of. Number 25. Some asteroids have their own moons. Even these small bodies can have little companions. In some cases, an asteroid system can have multiple pieces orbiting a shared center, showing that gravity will try to organize matter into orbits at almost any scale. Number 26. Jupiter is the largest planet in our solar system. You could fit more than 1,000 Earths inside Jupiter. It's mostly hydrogen and helium, like a star that never got big enough to ignite fusion. It's often called a gas giant for that reason. Number 27. Jupiter has a huge storm called the Great Red Spot. This storm has been observed for hundreds of years. It's larger than Earth and is a massive system of swirling winds. We've seen it shrink slowly over time, but it's still a monster compared to storms on Earth. Number 28. Jupiter has a very strong magnetic field. Its magnetic field is much stronger than Earth's and creates huge radiation belts around the planet. This field also helps shape the environment around Jupiter and can affect its moons. Number 29. Jupiter has dozens and dozens of moons. 4 of them, Io, Europa, Ganymede, and Callisto, are big enough to be worlds on their own. They were first discovered by Galileo in the early 1600s, and they're still some of the most interesting places in the solar system. Number 30. Ganymede is the largest moon in the solar system. It's bigger than the planet Mercury. It even has its own magnetic field, which is rare for a moon. Under its icy surface, it likely has a deep ocean of liquid water. Number 31. Europa might have a global ocean under its ice. Europa's cracked, bright surface looks like ice plates that have moved around. Signs from spacecraft suggest there's a salty ocean beneath that crust. That makes Europa one of the top places to look for possible life beyond Earth. Number 32. Io is the most volcanic place we know. Io, another of Jupiter's big moons, is covered in active volcanoes. Tidal forces from Jupiter and other moons constantly stretch and squeeze Io, heating it from the inside and driving constant eruptions. Number 33. Saturn is famous for its rings, but they're very thin. From far away they look solid, but they're made of countless bits of ice and rock, from dust-sized grains up to chunks the size of houses or more. The rings are only about tens of meters to maybe a few kilometers thick in most places, tiny compared to their diameter. Number 34. Saturn is less dense than water. If you could find a giant cosmic bathtub and drop Saturn in, its average density is low enough that it would float. Of course, the real universe doesn't work like that. but it's a fun way to show how puffy Saturn is. Number 35. Saturn also has many moons. Its largest moon, Titan, is bigger than Mercury and has a thick atmosphere. Many smaller moons help shape and shepherd the rings, creating gaps and patterns as they orbit. Number 36. Titan is one of the strangest worlds in the solar system. It has rivers, lakes, and maybe even seas, but they're not filled with water. They're made of liquid methane and ethane. Titan also has a thick orange atmosphere richer than Earth's in some ways, making it a key place to study for pre-life chemistry. Number 37. Enceladus, another Saturn moon, shoots out water from its south pole. We've seen geysers of water vapor and ice blasting out into space from Enceladus. That suggests a liquid ocean under its icy shell. The material in those plumes contains salts and organic molecules, making Enceladus another strong target in the search for life. Number 38. Uranus spins on its side. Its axis is tilted by about 90 degrees, so it kind of rolls around the sun like a ball. That means its seasons are extreme. One pole can be in sunlight for many years, while the other is in darkness. Then they swap. Number 39. Uranus is an ice giant. Unlike Jupiter and Saturn, which are mostly hydrogen and helium, Uranus has a lot more ices, things like water, ammonia, and methane, in different forms. The methane in its atmosphere helps give it a blue-green color. Number 40. Neptune is similar to Uranus but darker and more active. It's also an ice giant with a deep blue color. Neptune has strong storms and very fast winds. It was the first planet found using math. Astronomers noticed Uranus wasn't moving exactly as expected and predicted Neptune's presence before actually seeing it. Number 41. Neptune has the fastest winds in the solar system. These winds can blow faster than the speed of sound in Earth's atmosphere. That's a sign of how much energy moves through Neptune's atmosphere, despite it being so far from the Sun. Number 42. Pluto is no longer classed as a major planet. In 2006, astronomers changed the definition of a planet. Pluto didn't meet all the new rules, mainly because it shares its region with lots of other similar-sized objects. So it was moved into a new category, dwarf planet. Number 43. Pluto is part of the Kuiper Belt. This is a wide band of icy bodies beyond Neptune. Pluto is one of the larger members, but there are many others, some similar in size. It's like an outer asteroid belt, but made mostly of ice and frozen gases. Number 44. Dwarf planets are still planets in many ways. They're round due to their own gravity and orbit the Sun, but they haven't cleared out their neighbourhood of other debris. That's the key difference between a planet and a dwarf planet under the current rules. Number 45. The Kuiper Belt is the source of many comets. Short-period comets, which come back on timescales of decades or centuries, often come from this region. The Kuiper Belt is like a freezer full of leftovers from the early solar system. Number 46. Far beyond the Kuiper Belt lies the Oort Cloud. This is a very distant spherical shell of icy bodies that likely surrounds the solar system. We can't see it directly, but long-period comets that take millions of years to orbit the Sun probably come from there. Number 47. Comets are dirty snowballs. They're made of ice, dust, and rock. When they get close to the Sun, the heat makes the ice turn into gas, dragging dust with it and forming a glowing coma and tail. The tail always points away from the Sun, not necessarily behind the comet's path. Number 48. Some comets could have delivered water to Earth. Early Earth was hot and violent. Some scientists think a lot of our water may have arrived via comets and water-rich asteroids that crashed into our planet during its early history, adding new water and organic molecules. Number 49. Not all small bodies are simple. We've found asteroids with metal cores, contact binary shapes, two chunks stuck together, and surfaces covered in loose rubble. Some may be leftovers from larger bodies that broke apart in collisions. Number 50. The solar system moves around the galaxy. The Sun and its family of planets are not standing still. We orbit the center of our galaxy, the Milky Way, roughly once every few 100 million years, carrying the whole solar system with us. Number 51. The solar system has a bubble called the heliosphere. The Sun constantly blows out charged particles in all directions. The solar wind. This creates a huge bubble in space, the heliosphere, which extends far beyond Pluto and helps shield us from some of the radiation coming from the rest of the galaxy. Number 52. The edge of the heliosphere is not the edge of the solar system. We sometimes talk about where spacecraft have left the solar system, but what they really cross first is the boundary of the heliosphere. The Sun's gravity still reaches much farther, holding on to distant comets in the Oort Cloud. Number 53. Light from the Sun takes time to reach us. Sunlight takes about 8 minutes to travel from the Sun to Earth. When you look at the Sun, which you shouldn't do directly, you're seeing it as it was 8 minutes ago. The farther you go out, the longer that delay gets. Number 54. A year is different on every planet. A year is just one orbit around the Sun. On Mercury, that takes about 88 Earth days. On Neptune, 1 year is about 165 Earth years. Someone born on Neptune wouldn't even live long enough to see one full Neptunian year. Number 55. A day is also different on every planet. A day is one full spin on its axis. Jupiter's day is only about 10 hours long, so it spins very fast. Venus, as we said, spins so slowly that its day is longer than its year. These spins affect wind patterns, weather, and even the shape of the planets. Number 56. Some planets are slightly squashed. Because of fast rotation, planets like Jupiter and Saturn bulge at the equator and are squashed at the poles. They're not perfect spheres. They're more like slightly flattened balls. Number 57. Rings are not unique to Saturn. Jupiter, Uranus, and Neptune also have ring systems. They're darker and harder to see, but they're there, made of dust and small particles. Rings are more common than many people realize. Number 58. Moons can have their own mini-systems. Big moons can have thin atmospheres, oceans, and even other smaller objects in their influence. Some giant moons are more like small planets orbiting a bigger planet rather than simple satellites. Number 59. Some moons may have more liquid water than Earth. Bodies like Europa, Ganymede, Callisto, and Enceladus probably have deep oceans under their ice. These oceans could hold more water than all of Earth's oceans combined, locked away in the dark. Number 60. The solar system has more moons than planets by far. When you add up all the known major and small moons around planets and dwarf planets, you get hundreds of natural satellites. Many of them are still poorly understood and could hold surprises. Number 61. There are Trojan asteroids that share orbits with planets. These are asteroids that sit in special stable points ahead of or behind a planet in its orbit. Jupiter has many Trojans, and even Earth has a few known ones hanging around in its orbit. Number 62. There's a region called the snow line in the early solar system. Closer to the sun, it was too hot for water ice to survive. Farther out, beyond a certain distance, it was cold enough for ice to stay solid. This snow line helped decide which planets became rocky and which became gas or ice giants. Number 63. Gas giants likely formed faster than rocky planets. Once they got big enough, their gravity could pull in huge amounts of light gas from the disk before it disappeared. That's why they ended up so massive and rich in hydrogen and helium. Number 64. Planet migration probably reshaped the early solar system. Gas giants might not have formed exactly where they are now. They may have moved closer or farther from the sun over millions of years, disturbing small bodies and maybe even affecting the formation of Earth and the inner planets. Number 65. We have found objects that blur the line between comet and asteroid. Some asteroids show comet-like activity when they get close to the sun. They might have hidden ice under their surface that starts to evaporate, kicking off dust and gas. Number 66. The sun's activity changes over time. It goes through an approximately 11-year cycle where the number of sunspots, solar flares, and ejections of charged particles rises and falls. These changes can affect space weather and even slightly influence Earth's upper atmosphere. Number 67. Solar storms can affect technology on Earth. Strong bursts of charged particles from the sun can disturb Earth's magnetic field and cause geomagnetic storms. These can disrupt satellites, radio communications, and even power grids if they're intense enough. Number 68. Aurora lights are caused by the sun interacting with our planet. When charged particles from the sun hit Earth's magnetic field and atmosphere, they excite atoms high above us. When those atoms calm down, they release light. That's what creates the northern and southern lights. Number 69. There's no up or down in space. We draw the solar system with the sun in the middle and planets circling in a flat plane. But in reality, space has no preferred direction. North and south are just labels we attach to axes for convenience. Number 70. The planets are mostly in the same flat plane, but not perfectly. Most orbits lie roughly in a disk called the ecliptic plane, a leftover from the original rotating disk of material. But each orbit is tilted slightly differently, so it's not a perfectly flat system. Number 71. The order of the planets hides big gaps. When you see Mercury to Neptune on a line, they look evenly spaced. In reality, the distances between them grow huge as you move outwards. The outer solar system is mostly empty space, with worlds sprinkled very far apart. Number 72. Space between planets is not totally empty. There's dust, tiny particles, and charged particles from the sun. Space is a vacuum compared to Earth's atmosphere, but it still contains a thin soup of stuff drifting around. Number 73. Gravity rules everything in the solar system, from the way planets orbit to the shape of rings and the tides in Earth's oceans. Gravity is the main force. Even small changes in mass and distance can cause long-term changes in orbits over millions of years. Number 74. Tides don't just happen on Earth. Many moons are tidally locked because of the pull from their planets. Tidal forces can heat up the insides of moons like Io and Europa, driving volcanism and subsurface oceans even far from the sun. Number 75. Some moons are captured objects. Not all moons formed where they are. Some are likely asteroids or Kuiper Belt objects that got caught by a planet's gravity. Their strange orbits and shapes reveal that they had a different life before becoming moons. Number 76. The solar system has resonances that keep some orbits stable. For example, some asteroids orbit the Sun in simple ratios with Jupiter's orbit, like 2:1 or 3:2. These resonances can either protect objects from close encounters or slowly move them into less stable paths. Number 77. The inner solar system has been hit many times. Craters on the Moon, Mercury, and Mars are scars from a more violent past when impacts were common. Earth was hit too, but erosion, weather, and plate movement have erased many of the craters. Number 78. The late heavy bombardment may have helped life. There was a time early on when impacts were especially frequent. Those collisions were destructive, but they might also have delivered water and organic material and created environments where life could get started. Number 79. One giant impact probably changed Earth forever. The impact that formed the Moon didn't just give us a satellite. It also melted and mixed Earth's outer layers and may have affected our tilt and spin, which in turn influenced our climate over billions of years. Number 80. Earth's tilt gives us seasons. If Earth's axis weren't tilted, we wouldn't have strong seasons. Our 23.5-degree tilt means that during different parts of the year, different parts of Earth receive more direct sunlight. Other planets have tilts too, some more extreme, which lead to very different seasonal patterns. Number 81. Mars also has seasons. Because Mars is tilted and has an elliptical orbit, it has seasons like Earth, but they're longer because a Martian year is almost twice as long. The seasons affect its polar ice caps and dust storms. Number 82. Gas giants don't have solid surfaces like Earth. If you fell into Jupiter, you wouldn't land on a normal ground. You'd pass through thicker and thicker layers of gas and fluid. There might be a rocky or metallic core deep inside, but you couldn't stand on it the way you stand on Earth. Number 83. Ice giants may hide hot, strange interiors. Inside Uranus and Neptune, high pressures could create exotic forms of water and other materials. There's even an idea that deep inside carbon might form crystals and fall as diamond rain. Number 84. Outer planets have faint, distant rings and dust. Even when we don't see rings clearly, many planets attract and collect dust into faint ring structures. These can be fed by tiny impacts on moons or by material leaking from active surfaces. Number 85. The Sun will not stay like this forever. In about 5 billion years, it will run low on the hydrogen in its core and swell into a red giant. When that happens, the inner planets will be roasted and the solar system will look very different. Number 86. Before the Sun dies, its brightness will slowly rise. Even long before it swells up, the Sun will get a bit brighter over very long times. That means Earth's climate will change naturally over hundreds of millions of years, even without anything humans do. Number 87. The solar system has already survived a lot. Passing stars, moving gas clouds, and the galaxy's gravity have tugged on it over billions of years. Yet the main structure, the Sun and its major planets, has stayed stable enough for life to appear on at least one world. Number 88. We have sent spacecraft to every major planet. Probes have visited or flown by Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. We've landed on Mars, on asteroids, on comets, and on Titan. We've even flown past Pluto. Number 89. Voyager 1 and Voyager 2 are now in interstellar space. Launched in the 1970s, they visited the outer planets and then kept going. They've crossed the edge of the heliosphere and are now traveling through the space between the stars, still sending back data. Number 90. New Horizons gave us our first close look at Pluto. For most of history, Pluto was just a blurry dot. In 2015, New Horizons flew by and showed us a world with mountains of ice, smooth plains, and a surprisingly complex surface for such a small, cold place. Number 91. The solar system is one of many in the galaxy. For a long time, we didn't know if other stars had planets. Now we've found thousands of exoplanets orbiting other stars, and many of those systems look very different from ours. Number 92. Our solar system might not be typical. Some systems we've found have giant planets very close to their stars, or lots of planets packed into tight orbits. Others seem to have mostly smaller rocky worlds. Our layout, small inner planets and big outer giants, may not be the most common pattern. Number 93. Studying our solar system helps us understand others. By understanding how our planets formed, evolved, and interact, we can make better guesses about what's happening around other stars. Our backyard is the training ground for learning the rules of planetary systems. Number 94. The solar system is still changing. Moons slowly drift away from their planets. Orbits shift slightly over time. Rings may thin out or rebuild. Even though it feels fixed, over millions and billions of years, the system is dynamic. Number 95. We are already changing the solar system in small ways. Our spacecraft leave traces, we crash probes into moons, and we may move resources around in the future. Compared to the scale of the system, it's nothing. But in a way, humans are now one of the forces acting inside it. Number 96. There is no clear edge to the solar system. You can define the edge in several ways. Where the sun's gravity loses control of comets, where the heliosphere ends, or where the influence of other stars becomes stronger. In reality, it's a gradual fade, not a hard border. Number 97. Time moves differently in strong gravity. Close to massive bodies like the sun, time runs slightly slower compared to far away. The effect is tiny in our solar system, but it's real and matters for precise systems like GPS satellites. Number 98. Even empty space is shaped by magnetic fields. The sun, planets, and even some moons have magnetic fields that stretch far into space. These fields guide charged particles, carve out cavities in the solar wind, and can create complex interactions between neighboring bodies. Number 99. We've probably only scratched the surface of what's out there. Many small moons, asteroids, and distant icy bodies are still undiscovered. New telescopes and missions will keep adding to the family photo of our solar system for decades to come. Number 100. You live in a tiny corner of an already tiny system. Our whole solar system is just a speck in the Milky Way, and the Milky Way is just one galaxy among countless others. But from this small system, on this small planet, we're already mapping the neighbourhood and asking questions about our place in the universe. So now, when you see that simple picture of the solar system, you'll know it hides storms older than empires, oceans under ice, tilted worlds, wandering rocks, and a star that quietly powers everything you've ever known, all held together by gravity and time. If you want more videos like this, subscribe for more space stories like this one.